The worst industrial accident in American history made Texas City synonymous with disaster. The day it happened, Will Lane was very near the epicenter.
It was very strange. I'm really glad to be alive.
Lane was a young chemist at the Monsanto chemical plant. He remembers seeing the bright orange smoke from a burning ship. Firefighters were busy pouring water on the French freighter Grand Camp at the city docks across from the Monsanto plant.
You could look at it, it's real pretty to watch. And there were townspeople by the hundreds that lined the part of our parking lot that was nearest the ship. They came down to watch the fire.
Texas City had a new fire truck, and this was its first day out. 27 firemen were on the docks trying to put out the fire. The burning ship was so hot, the water around it was boiling. But as a chemist, there was something about that orange-colored smoke that worried Will Lane.
We could see bits and pieces of paper bagging going up through the air and away, and my boss thought, and I thought too, that we were witnessing a nitrate fire, but someone had said, it's a grain ship, the grain is on fire.
So believing it was only a matter of time before the fire was out, Will Lane went back to work at the Monsanto lab. But the fire was growing hotter, and the orange smoke was attracting an even larger crowd along the docks.
It was a very, very strong sulfur in the air, sulfur fumes.
Herb Metzger watched the fire while talking to a group of high school kids.
This smoke was just a beautiful orange.
Mary Hunter, a Monsanto secretary, was watching from her office window.
And across town, Mrs. Knappenberger, a housewife with a home camera, came here to the Texas City dike to get a closer look at the burning ship. She didn't know it then, but she was about to record America's greatest man-made disaster.
The ship had been loaded not with grain, but with ammonium nitrate fertilizer, the same ingredient that would be used years later in the Oklahoma City bombing. The Texas City blast was so strong it registered as an earthquake in Denver, 900 miles away. It created a tidal wave that washed a barge into a parking lot. 2 airplanes circling the ship were blasted from the sky. Flying debris punctured chemical storage tanks, creating an even larger inferno.
We have another truck up here off of the road. It had about 10 or 15 men, and they were all crushed.
The explosion killed at least 581 people, including school children who had come to watch the fire. But the danger was far from over. Tomorrow, we'll hear the stories of survival and courage from the people who were there 50 years ago. Charles Hadlock, 11 News, Texas City.
Just think about
This is Charles Hadlock. Texas City has tried to outlive its past, but it's hard. There are so many reminders. An anchor here, a propeller there, and sad, sometimes painful memories all around.
Even today, 50 years later, the tragedy is not forgotten. 6th Street, the once busy main street of Texas City, has been renamed the Street of Memories. For it was along this street that so many screamed and ran for their lives.
The explosion of the French freighter Grand Camp left an entire town dazed and confused.
And I ran as fast, as hard as I could.
There are many stories of survival. Dr. Will Lane was in the Monsanto lab. He had been watching with suspicion the bright orange smoke of the burning ship docked next to the plant when it suddenly exploded.
And when the lights just went out, I could not see more than 2 or 3 feet. And I thought, my God, it was a nitrate explosion. I'll probably lie right here and be burned to death.
He got up, looked over his shoulder at the burning tanks of benzene, and ran for his life.
Passed a car in which 2 people had been decapitated. Then I passed one of the 2 little planes that had been flying around overhead, came down along the path that I took up into town.
I'm sure all that glass came into us, and I must have gone like this. And so my arm was injured all in here.
Mary Hunter was also in the Monsanto plant. To this day, she still has shards of glass in her body.
I had it cut out of me, but luckily it had lead in it. And therefore when they x-rayed they could find the glass.
Before the explosion, hundreds of people were on the docks, including Herb Metzger.
I had turned to walk away. I had my back to the explosion, but the force hit me in the back, and it sort of just, I don't know, I would say it picked me up, but it moved me forward 20 or 30 feet.
Suddenly, pieces of the ship were falling all around him. He crawled under a car.
A couple of pieces hit the car. I could feel it, you know, and it jarred, but nothing hit me.
Here comes another explosion.
But pieces of metal did hit the High Flyer, a second ship loaded with ammonium nitrate. Efforts to tow the burning ship out to sea failed, and 14 hours later, it exploded. The fires burned for days. Nearly 600 people died, and 5,000 were left injured or homeless. Those who survived helped each other.
Well, we had to pry some folks out that had telephone poles, in fact, I guess, or some kind of big poles blown across them. They obviously were crushed, you know. It was not a nice sight, but kind of steeled myself to it for a while.
Even after the dead were buried, many survivors never talked about it again. But over the half century since the explosion, they rebuilt their lives and their city. That must have been a hard thing to do, with so many memories around. Charles Hadlock, 11 News, Texas City.
Yeah, so back to ammonium nitrate. What makes ammonium nitrate so dangerous is because it's...
Drainage property damage.
Well, there's lots of videos on Texas. Is because of this. On the one hand, you have ammonium, which is what we call electron rich. Now, on the other hand, you have nitrate, which is electron poor. And so this is like, okay, one nitrogen's -3, the other nitrogen's +5. If they got into a tug of war, is that, what do you think is going to happen? There's going to be a reaction, right? So as long as the two hands are separate, that's okay. And they are separate because they're locked in a crystal lattice. But if the vibrations of that lattice get big enough, right, then as the ammonium nitrate gets hotter and hotter, what's going to happen? Yeah, those two nitrogens can collide with each other, and if they collide, if the ammonium collides hard enough with the nitrate, you're going to get a redox reaction because this is totally inequitable. -3 for one nitrogen, +5 for the other. But it's stabilized as long as it doesn't. As long as the temperature is low, you're okay. But what are you guys going to do with your ammonium nitrate that you just generated? You're going to heat it up, and you know they're talking about the orange gas. The orange gas, of course, is NO2. NO2 is, you know, brown orange gas. Oh, and it smells awful. It's toxic, but you're going to get some kind of redox reaction happening. And so, what's going to prevent a little mini Texas City in your evaporating dish? Well, one, the mounts. You know, the mounts are very small. Hopefully you got rid of most of the ammonium already, right? Just getting the last little bits of ammonium out of there. But, you know, if you're not careful and you have lots of ammonium and lots of nitrate, you're going to have a little mini Texas City in your evaporating dish. Fortunately, we haven't had that. And so just make sure you follow the procedure at this point. And just do it in the hood. You know, don't do it out on the bench. Okay? Don't use a Bunsen burner. Just heat it on a hot plate. A Bunsen burner can get it very hot. Question? It's soluble in water, but you evaporate all the water. There's nothing left it can do except precipitate out. Yeah.
What if we add too much nitric acid? Like instead of 5 to 6 drops, we add 17 drops.
Of nitric acid?
Yeah.
If you add lots of nitric acid, then you have potential for more violent reactions. Yeah. But hopefully there's not much ammonium, so it probably won't make much difference. Yeah. most of it's going to be burned off, the previous step, I think. All right, and then we continue. We continue on with the zinc. We get rid of this ammonium nitrate by. This is a more gentle reaction. Hopefully, it's more controlled. But this is going to form what?
Laughing gas.
Laughing gas, which is nitrous oxide, and water vapor. Is that it? All right. So we got 2 nitrogens, 4 hydrogens. We'll need 2 waters, and 3 oxygens. So this is balanced. You know, under these conditions, we should form nitrous oxide and water, but under other conditions, we can form nitrogen gas and other oxides of nitrogen. In fact, we can form a lot of moles of gas. And so normally what happens in a detonation or explosion of this sort is you go from a very small volume, like a solid, to a very large volume, like gas. You know, and so we're going from a very small volume, let's say I had a mole of ammonium nitrate, it doesn't take up much space, right? But to go from a mole of ammonium nitrate to 3 moles of gas, then all of a sudden you're going from something well under a liter to about 75 liters worth of bulk. And if that happens rapidly enough, then you'll get a detonation, you know, shock wave, that kind of stuff. They have different, you know, they have different terms. Deflagration, you know, which is like a high speed flame, versus like a detonation where it travels faster than the speed of sound, that kind of stuff. You know, these types of things, depending on how it decomposes. But hopefully ours will be nice and under control, and it is. In fact, it's not too bad. All right, after this, what do we do next? Sodium hydroxide? No, HCl?
HCl 6N.
Okay. Well, the zinc chloride, you know, what we're going to do with the zinc chloride at this step is just redissolve it and then just re-solidify it, right? And so the zinc chloride will dissolve in the nitric acid, and then when you heat it to dryness, again, it'll be solid. So what we're going to do is we're going to take that solid zinc chloride out of here, which would be the residue or the precipitate from 5 plus HCl. This is just to rehydrate it, right, to just get it back into aqueous phase so we can continue the analysis. And so we end up with the CCS here. And so we have zinc chloride solid plus, well, actually, this is just a physical dissolution. We're just dissolving it to get it back in to aqueous solution. Okay, 7. What do we do with the zinc chloride? We add sodium hydroxide.
10 drops of water first.
10 drops of water. And then what?
Yeah,
Transfer to test tube, wash out evaporated dish, basically clean it up, and sodium extra acid solution.
And then add sodium hydroxide. All right. So HCl, the water, oh, I don't know if we want to do that. And so what we're going to do is we're going to take solution from 6 and then add sodium hydroxide. And then what forms here?
The zinc hydroxide compound.
The tetrahydroxyl zincate or zinc hydroxide? Tetrahydroxyl zincate? Zincate 2, right. Tetrahydroxyl zincate 2. Oops, this is not what I wanted to write here. So we do this, we get CCS again. It looks like nothing happened. And so with the zinc ions, what they're going to do is they're just going to complex with the hydroxyl ligands, 4 of them, form this. Okay, then what?
You can wait.
Then you add
Oh,
the
it is
HCl
there.
and the hexacyanoperic potassium. Yeah, potassium hexacyanoperic too.
Okay. So-
Centrifuge and get the solid out.
All right, so we'll take this CCS,
And then decantate.
so the solution 7, and then add HCl to this?
They had it as first potassium hexacyanoperic and then the HCl.
Okay. Potassium hexacyanopherate 2.
2, yes. 4.
And then what happens with the potassium hexacyanopherate?
That's when you get
The gray blue flavor. And then
the gray blue. So the zinc 3, 2.
So we get gray blue PPT?
Yes.
maybe acidify with hydrochloric first.
Yeah.
Okay, we acidify with hydrochloric. I'll put that under here. And then what?
You get
The precipitate form.
A precipitate?
That's the gray blue precipitate.
Gray blue precipitate?
It's definitely a complex.
Gray blue precipitate. Is that right?
Mm-hmm.
So what's happening here then? What am I forming? Well, the HCl to do what? The HCl must be to destroy the complex. So I'm going to write 2 equations here. And so we'll take our complex with 4H plus. This should form Zn2 plus 4 waters. Then once I have the Zn2 plus free, then I'm reacting it with what?
Apparently
The hexacyanopherate? And what does it form?
Okay. Is that zinc, potassium, hexacyanoperic 2?
Okay, so where did the potassium ions come from?
From the potassium.
Hexacyanopherate? Okay, so I'm going to have zinc, potassium, and hexacyanopherate, correct? And then in what ratio am I going to have the zinc to potassium? 3 to 2?
Yeah, 3 zincs to potassium.
All right. 3 zincs to
2 potassium.
2 potassiums.
And
The-
hexacyanoperic.
2 hexacyanoperic.
Yeah, there's 2 of those molecules.
Or ions?
Just 2 potassium.
Ions.
Okay.
Just 2 potassium and there's 1.
And then water.
Wait, no, never mind.
And water? How many waters?
Definitely. And you also forgot the H plus.
All right, I already did the water here.
Oh,
But okay, looking at this though, what we got is a mixed cation salt here. And so when we have mixed cation salts, the nomenclature gets screwed up. And so this is why some people are suggesting that we should use the tri-di prefixes for all compounds. Because then it wouldn't get screwed up, because how would you name this? According
to be dipotassium triazine.
right, otherwise it's hard to name, because we could have different combinations of zinc to potassium. For example, we could have 1 zinc and 2 potassiums. That would work. And so, well, this must be what forms. This is insoluble salt, and so it's a mixed cation salt, and it forms some kind of lattice, which is stable enough to precipitate like this. And so some people would call this trizinc dipotassium hexacyanoferrate 4 or 2. Hexacyanoferrate 2. All right, so this would be the positive test for zinc. All right, any questions? No? We'll stop here and then you get to work.
Wait. So, Sandra, you're only doing the zinc.